1 maternal line clue, 2 rounds of cousin marriage. Use energy instability to make sense of Darwin's symptoms. Use the consanguinity magnifying glass to understand why his children were so fragile. Quick disclaimer. This episode is a retrospective medical hypothesis. That means we're using today's medical lens to look back at what might have been happening. It is not a diagnosis, and it is not medical advice. The biggest limit of any retrospective hypothesis is what we do not have. No physical exams, no lab tests, no imaging, no genetics, no pathology. So what follows can only be careful reasoning. We're talking about what is compatible, not what is proven. Darwin's life runs on 2 tracks. One track is in textbooks, the voyage of the HMS Beagle, coral reefs, fossils, natural selection, and on the origin of species. The other track lives in private letters, nausea, retching, vomiting, abdominal pain, headaches, dizziness, palpitations, sweating, trembling, and nighttime fear. It's hard to imagine those days on his desk, unfinished notes. In his mind, a theory he hadn't made public yet, but his body felt like a runaway alarm system. You silence one alarm and another one goes off. For 2 centuries, people have assigned him over 30 diagnoses. But the more labels you stack up, the more it feels like a clue. Maybe we kept using single-organ language to describe something that was multi-system, episodic, and recurring. Act 1. On the ship. The Beagle was like a massive rocking machine. It pushes the balance system to its limits. For some people, it's temporary discomfort. For others, it's like a key that fits perfectly into a vulnerable lock inside the body. Darwin's seasickness wasn't throw up for 2 days, then adapt. It was more like constant overload. His stomach churned, his head began to ache, and the dizziness folded the world into a sheet of paper you can't stand on. You think you can power through with willpower, but the body doesn't negotiate. It only knows it's losing stability. So the body's emergency systems slam fully on. Heart racing, sweating, trembling, hot and cold flashes, chills and feverish waves. Like the alarm volume is turned all the way up. The worst part isn't daytime. The worst part is night. You wake in the dark with no warning. Your heart pounds like it's running for its life. Your stomach feels like it's capsizing. And your mind collapses into one thought. Am I dying? That isn't drama. When a physiological alarm detonates at night, without warning, anyone would be terrified. Act 2. Marriage and moving. In 1839, he got married. In theory, this is when life stabilizes. A partner, children on the way, a steady roof overhead. They made what seemed like the most reasonable choice at the time, leave London and move to Down House. Cleaner air, slower pace, as if a better environment would fix the body. But the episodes didn't stop. His stomach still flipped, his head still spun. Palpitations, sweating, trembling, still crashed down without warning. Some days he could only lie there as if the power cord had been pulled. Some nights he woke in terror as if his body, in the dark, secretly pressed the alarm button. The brutal truth is this. A better environment did not clearly change the course. If the internal control system is unstable, the gentlest countryside can only be a backdrop. Act 3. Putting the symptoms together. If you lay all his symptoms side by side, it looks like a symptom cloud. Each episode feels like a storm. The eye of the storm is often the gut. But the wind whips into the head, into the heart, into mood and sleep. First main thread, the GI system. Nausea, retching, vomiting, episodic and cyclical. During attacks, he was profoundly weak, like his whole body had been emptied out, often with abdominal pain, bloating, and digestive distress. And this part matters. Stress, excitement, fatigue, heat, travel, all could ignite it. Second thread, headaches and dizziness, often tied to the GI episodes. It reads more like a migraine spectrum shadow, not just a simple headache. Third thread, severe motion sensitivity. Travel was a trigger field for him, not just poor tolerance. On the Beagle, he was sick for a long time, like a system stuck in overdrive. Fourth thread, autonomic storms, palpitations and chest discomfort, sweating, trembling, hot-cold swings, dizziness, collapse-like weakness, even near fainting. This cluster can easily be labeled a panic attack. But remember, sometimes the body destabilizes first, and fear is what the destabilization creates. That intense sense of impending doom can appear in many physiological breakdowns too. Fifth thread, nighttime terror. He described waking suddenly at night, extremely frightened, crying, with a powerful feeling that he was about to die. That's easy to stamp as purely psychological. But if it repeats and runs alongside GI symptoms and autonomic storms, it looks more like one system dropping offline. Why did later writers give him so many diagnoses? Because his presentation was unbelievably good at disguising itself. It looked like stomach disease. It looked like anxiety. It looked like an inner ear problem. It looked like nervous exhaustion. So, over 2 centuries, people proposed more than 30 diagnoses. Each could explain part of it. Few could explain the entire combination. That's why some have proposed a more upstream framework. Think of it as energy instability. By energy, you can imagine cellular power supply. If the power supply fluctuates, the first problems often aren't confined to one organ. They hit the systems that consume the most energy and require the tightest regulation. The brain and nerves, the autonomic control system, the gut's neural network, the heart, endocrine system, muscles. That also explains why it can look like stomach disease and also look like psychological. Some have compared Darwin's pattern to the mitochondrial disease spectrum. They even reference a common framework, MELAS, and the M3243A to G related spectrum as a possibility. They argue that Darwin's cluster, cyclical vomiting, migraine-like headaches and dizziness, severe seasickness, autonomic symptoms, nighttime terror, is compatible as a puzzle fit. But we must emphasize, we lack key evidence, like lactate data, imaging, genetic testing. So this remains one hypothesis among many. Zoom out to the mother. The maternal line clue comes into focus. If you look only at Darwin, you can get stuck in stomach disease or anxiety. But when you pan to his mother's line, a structure appears. His mother was Susanna Wedgwood. Clues include vomiting and infection-like issues early in life, a difficult pregnancy course, possibly like hyperemesis, greater sensitivity to motion, long-term frailty with frequent need to rest in bed, and death from an acute abdominal illness. None of this is a diagnosis, but within an energy instability framework, it isn't out of place. And here's the key. mtDNA is mostly inherited from the mother. So when you see a mother with related clues, a son with a similar gut dizziness, palpitations/sweats, extreme fatigue pattern, plus what we covered in the previous episode, the Wedgwood maternal family showing scattered, multi-system symptoms, it becomes natural to think, maybe this isn't just individual psychology. Maybe it's a maternal background showing different faces in different people. The brother, a lighter version of the same thread. Darwin's brother, Erasmus Alvey, Darwin, also has records of abdominal pain, fatigue, sleepiness, and pallor. Today, someone might label that as a chronic fatigue-type picture. In a mitochondrial spectrum narrative, families often show a wide range, some severe, some mild. You can think of it in two parts. First, people inherit different bad battery ratios. Second, the bad batteries may be distributed differently. For one person, it hits the gut more. For another, the nervous system. For another, it shows up mostly as fatigue or headaches and dizziness. Some family studies also note, even with the same variant, siblings can differ dramatically. Some develop stroke-like episodes. Others show only diabetes or migraines. Chapter 4. Why might he have been better later in life? Here's a detail that feels counterintuitive. Why did Darwin seem somewhat better in later years? Some research suggests that in certain mitochondrial variant carriers, the proportion of mutant mtDNA in peripheral blood may decline with age. Some even estimate it as about a 2% correction per year. But that does not mean the same happens in key tissues. A decrease in blood does not guarantee decreases in brain or muscle. Tissue differences can be large, and changes in proportion do not guarantee symptom relief. So we can't simply say he got older, so he got better. But in some people, it may reduce part of the systemic burden. Second main thread, consanguineous marriage as a magnifying glass. Now we move to the second track. First, a clarification. Cousin marriage does not create mtDNA variants, but it does increase the chance that certain recessive risks in nuclear DNA will match into two copies. In other words, it can amplify what was already hidden. Darwin and his wife Emma were first cousins. Emma was the daughter of Darwin's maternal uncle, and in Emma's parents' generation, there was also a background of distant cousin marriage. So effectively, two layers of cousin marriage were stacked. As a result, their children's inbreeding coefficient was about 0.063. That is 6.25%. That means their children were more likely to carry longer runs of homozygosity, making recessive harmful traits more likely to show, and it could make them more vulnerable in early childhood. Also, Darwin's sister Caroline married Emma's brother, Josiah III. They were cousins as well. So in that era, marriage within a close family circle was not unusual. Why Darwin worried? Because he saw the answer first in plants. Darwin didn't begin worrying after marriage. He almost walked into marriage already worried. Around the time of his marriage, he ran long comparative experiments. In the same species, inbred offspring often grew weaker, while outcrossed offspring were stronger and more vigorous. He wrote these observations into The Effects of Cross and Self-Fertilization in the Vegetable Kingdom, systematically comparing germination rates and growth speed. Even more striking, some reviews note that before marriage, he had read a book discussing marriage and health. So, he was especially alert to the potential consequences of cousin marriage. That creates a dramatic contrast. One of the earliest people to experimentally argue that inbreeding can be harmful ultimately married his own cousin. Of course, humans aren't peas, but scientifically his concern wasn't irrational. 10 children, the curve under a magnifying glass. Darwin had 10 children. 3 did not survive to adulthood. Of the 7 who lived, only 3 had descendants. You can interpret this as genetics. You can also interpret it as the era. In the 19th century, infection pressure, nutrition limits, and medical conditions were enough to take many children in infancy and early childhood. But Darwin's suffering wasn't only grief. The deeper torment was long-term worry. He feared his own constitution, and he feared that marrying his cousin might bring misfortune to their children. He recorded them like a scientist, their smiles, fears, illnesses, recoveries. He faced the reality of which offspring were selected by frailty and disease, and that sits in profound tension with his work on natural selection. Cousin marriage acts like a magnifying glass. It lowers the overall health threshold, especially early in life. The children's illness pattern did not mirror the father's. Childhood was heavier. Survivors often stabilized as adults with normal lifespans. It resembles getting through a narrow gate in childhood. In an era of high infection pressure, if the baseline health threshold is lower and recessive risks are slightly higher, children are more likely to be hit early. Now, a quick look at all 10 children. First, William Erasmus. Overall active and healthy as an adult. Married with no children. A reminder, having no children does not equal infertility, but in family discussions it is often brought up. Second, Annie Elizabeth. Died at age 10, a long illness after an acute infection, scarlet fever, later thought to possibly involve a tuberculosis process. Magnifying glass view. Childhood infection pressure plus a lower constitution threshold was a common lethal combination then. Third, Mary Eleanor. Did not thrive after birth and died at 3 weeks. Possibly neonatal complications or infection. Magnifying glass view, infancy is extremely sensitive to environment, and small differences can be amplified fast. Fourth, Henrietta, Etty. A severe illness in childhood, later shifting into chronic difficulties, but she recovered in adulthood and lived a long life. No children. Magnifying glass view, fragile in childhood, stable after passing the critical window. Fifth, George Howard. Stable in adulthood, high academic achievement. Had 5 children. His eldest son died in infancy. Another son had mild intellectual disability. The other 3 grew up, married, and had families. Magnifying glass view. Variation among siblings can be large. That fits a model of probabilistic amplification, not a destiny verdict. Sixth, Elizabeth, Bessie. Never married. Sources note tremor, facial grimacing, or small repetitive movements. Tic-like features. To be clear, tic-like movements are not specific. They can appear in many contexts: child development stages, stress, medication effects, or primary tic disorders. So this alone cannot point to one cause. But in some genetic metabolic brain disorders, various involuntary movements can occur: tics, myoclonus, tremor, dystonia, and more. You can think of it this way. When brain motor control circuits have unstable energy supply, braking and rhythm control can briefly slip, and these movements can surface. Still, it's a puzzle piece, not an anchor. Seventh, Francis, Frank. No major disease records. Stable adulthood with descendants. Magnifying glass view, again. Not every child is affected. It's that the risk distribution is wider. Eighth, Leonard. Frail in childhood, long recovery after scarlet fever. Healthy and long-lived as an adult. Married twice, with no children. Magnifying glass view. Passing the narrow gate in childhood, then stabilizing in adulthood, is typical. No children cannot be pinned on one single factor. Ninth, Horace. Childhood episodes of spasms, tremor, and emotional outbursts. Later decreased and resolved in adulthood. High achievement with descendants. Magnifying glass view, childhood neurobehavioral episodes often reflect a mix of environment, stress, and constitution. Adult recovery suggests reversibility and developmental change. 10th, Charles Waring, died in early childhood. Sources note a possibility of Down syndrome in the setting of advanced maternal age and increased susceptibility to infection. Magnifying glass view. Congenital factors plus infection pressure plus consanguinity background may have compounded, but we still cannot assign weights to each factor. Overall summary of the children. The overall trajectory looks like this. Childhood risk was amplified. More infections, more frailty, more early deaths, and more reproductive issues in some, but not universally. Adulthood often brought stability and longevity. That kind of splitting fits a model where consanguinity widens the risk distribution. Now merge the two threads. Put both tracks on one map. In the previous episode, we discussed a key anchor, Darwin's aunt, Marianne. Her severe presentation makes the maternal line clue feel more concrete. Combined with other family members' multi-system symptoms, that maternal background looks like one puzzle piece. In this episode, consanguinity functions like a tool. It does not manufacture mitochondrial variants. It acts like a magnifying glass. It makes recessive nuclear DNA risks more likely to pair into two copies. It makes early life windows more fragile, and it makes environmental pressure more likely to amplify risk. So what you may be seeing is a two-channel background. Darwin's long-term multi-system symptoms are compatible within a maternal energy instability hypothesis. His children's greater childhood fragility, more early deaths, and some reproductive issues are compatible with a model where consanguinity amplifies recessive nuclear DNA risk, and together they make the family health history more complex, more scattered, more dot-like. This also explains why Darwin was so often misread as stomach disease or pure psychology. Because energy instability tends to hit first exactly the systems that look like that: the gut, autonomic regulation, and the brain's control systems. It naturally presents as, it looks like GI, but it also looks like anxiety. Closing for today's viewers. Don't let "it's just psychological" end the search. Many patients within the mitochondrial spectrum go through a long diagnostic journey. Before the underlying cause is found, they're often repeatedly misdiagnosed as psychiatric conditions or as other hard-to-explain chronic pain and fatigue syndromes. If you or your family shows a Darwin-like pattern, multi-system involvement, episodic attacks, a confusing chain of symptoms, please don't accept "it's just anxiety" without further evaluation. You can use 3 questions as a reminder. First, is more than one system fluctuating? For example, vomiting or abdominal pain episodes, plus headaches or dizziness, plus extreme fatigue or brain fog. There may also be nighttime terror, emotional collapse, sweating, or rapid heartbeat. If 2 or more show up together, it more strongly suggests a systemic issue. Second, are there clear triggers? Infection, stress, sleep deprivation, heat, travel, physical exertion. If symptoms reliably worsen under those conditions, that pattern suggests there may be a metabolic threshold, not just imagination. Third, is there a family clue, especially on the maternal side? Symptoms don't have to be identical, but relatives may have migraines, recurrent vomiting, seizures, unexplained fatigue, balance problems, diabetes, hearing loss, or other neurological issues. These conditions can look diverse in families, but may cluster more on the maternal line. If at least 2 of these 3 answers are yes, don't let your care journey end with "you're too sensitive." see a qualified clinician. Ask whether inborn errors of metabolism, IEM, and the mitochondrial spectrum should be considered in the differential. The goal isn't to chase a flashy label, it's to avoid misdiagnosis, reduce dead ends, and prevent missed diagnoses. Darwin's story reminds us, what looks purely psychological may have a very real physiological cause, sometimes even a genetic one. In medicine, curiosity and rigor truly matter. If you're interested in stories at the intersection of inherited metabolic disorders, IEMS, and mental health, including cases of metabolic psychosis, you can check out the full written version in the Junyi column.